Okay, so the agenda today is the following. First, I'm going to talk about the challenges in data science encapsulation, reproducibility, and deployment. Throughout this conference, we've heard a lot about this topic and how Jupyter helps you in some ways in like the reproducibility, but there's still a lot of left to like really accomplish a lot of the challenges that data scientists face when they're trying to reproduce someone else's code or someone else's analysis, or when they want to move their analysis to like a different platform or a different system when they want to deploy it. We're going to talk about how a new open source project that's being developed at Continuum Analytics called Anaconda project can help data scientists encapsulate their projects. And then we're going to see how you can use Anaconda project with JupyterLab with an extension that we've also created. And then how Anaconda project and JupyterLab really power the Anaconda Enterprise product that we're selling to enterprises. So let's start with the challenges in data science reproducibility and deployment. So in terms of reproducibility, this is a little bit like what doing data science looks for a lot of people, right? You have your laptop, you get Python, you get your R, you start getting some like packages, you install it either Pip or Conda, and then you start generating some scripts that do, some Python scripts that do some stuff. You have a notebook here, you generate some data set, you have it left around your laptop, and then you might have things like I need to connect to like a database to get some information, or I need to get connect to like my an S3 instance with some like auth permission to download some other data set. And so once you start like this, and then it comes and says like, okay, now what, right? Like now how do I share this with someone else in my team? How do I put this in like a production system and deploy it? What do I actually want to generate and share with other applications or other users? So this is one of like the kind of like images. Then we also have the deployment story, right? So I'm a data scientist, I have some data, I clean it, I tidy it, I do like some predictions or simulations, I visualize some data, I query and kind of do it over again. And then we're saying like, okay, what things are we actually generating? What are our outputs? And there's like a variety, right? Like sometimes it's just like process data, doing some kind of transformation on your data and generating an outcome. Sometimes it's like the Jupyter Notebook itself is like the output that you're giving to someone else to read as a report. Some other times you like want to produce like dashboards so that your consumers of your data science project can interact with it. Sometimes like, there's a lot of people building predictive models that might be used in other applications. And usually people do it things like deploying as REST APIs. There's sometimes like workflows, right? Like there's like a pipeline, a process that you need to repeat it in like with a certain frequency. And there's like just like some scripts that you just want to have there and like run them kind of like whenever you need them. So there's like a variety of things that get generated. So how do we make sure that we're deploying it with the right dependencies and the people and other applications can consume them? So these are kind of the two big topics in this presentation. What challenges do data scientists face when they're trying to do both of those things? First is data scientists work in very different platforms. There's like some Macs here, some Linux systems, some Windows. And then when they go and deploying them, like in your production environment, it also might be a different platform than where you're developing it. Another challenge is that data science dependencies are more than just software packages. You sometimes have dependencies like can be data, it can be environment variables that you've set up in your system, it can be commands that you have to run to execute your analysis or your project, or it can be dependency like services that you need to stand up in order to run your project. So how do you package all those things so that when someone gets it, they can also stand it up? Managing software packages is not just like getting the package, but then like in terms of reproducibility, knowing what version you're getting, from where you're getting it. Sometimes it's like, who built it, and what guarantees they're giving you. Then there's like the other challenges that a lot of this like deployment capabilities are really being focused for developers, and they can go like a depth that data scientists really don't want to go that deep. And like there's like a lot of people using Docker to deploy their data science projects, but it can be like a big overhead for data scientists that just want to kind of like ready, click a button and be ready to go. And there's also like this like variety of deployment types. You know, sometimes you want to deploy it just like a notebook for someone to run by themselves. Sometimes you want to deploy a REST API so another web application can consume it. Sometimes you want to create a dashboard, and sometimes you want to create kind of an intelligent web application that someone else can use and kind of like consume like that data science machine learning model. So we're going to see how different projects in the Anaconda ecosystem can help you overcome those challenges. So the first one is what we call Anaconda project, and it is an open source project that's developed at Continuum. And we're going to see a little bit like how we evolved from the Anaconda distribution and from Conda to get to this like configuration setting to encapsulate your data science. So a lot of people here are probably already familiar with Anaconda and the Anaconda distribution. So Anaconda distribution and Conda make data science reproducibly in the deployment already easier than it would be without them, right? So with them, you have now your laptop or your desktop. You want to do some data science development. No matter what system you are, Windows, Mac, or Linux, you can install the Anaconda distribution. And then like the Conda environments give you this isolation so that you can like control what dependencies your different analysis need and make sure that you can have different versions of pandas or the Jupyter notebooks or JupyterLab in your environment. And then when you go and share with someone else, or when you go and like deploy it into a system, you can still get Anaconda, you can still get stood up those environments and have them run those analysis. Some people have, as I mentioned before, like to solve kind of like the deployment story, there are already Docker images for Anaconda. So they can start from there, they build their own. So they kind of like make the DevOps developers happy to deploy their analysis just using the same infrastructure they're using as well. But as I mentioned earlier, maintaining those Docker containers can be a little bit of an overhead for the average data scientist, which like does not want to get into the weeds of managing all the like different commands and like the different needs that you need to like take into consideration when building those Docker images. So basically, with Anaconda and Conda, data scientists can manage their software dependencies across platforms, and they can isolate and recreate those environments, no matter in what machine or platform you're working on. But we're going to see that that's not enough, right? We've mentioned already that there's like other dependencies other than your software packages. So that's when we like started this project, and now it's been almost, I think, 2 years of Anaconda project. And now it's available in the Anaconda distribution. And it's an open source project that helps you encapsulate all these other additional dependencies that your project might have. So basically, Anaconda project is just like a YAML configuration that has the right abstraction for data scientists. It has things that we can relate to. So it has like a name of your project, your description, then like different commands that you need to run to like execute your project. Sometimes it can be like a bokeh command, bokeh serve this application. It can be like a Jupyter notebook command, and you need to like stand up the notebook that you want to serve. It can be just like a bash script or a Python script. So you can name all those different commands that you might want to expose your deployment in an instance. Then you might have also data dependencies or download dependencies, extra that you want to, you don't want to check into GitHub if you have like a CSV file, and you just want to point it to where it lives and make sure that when you run your project, that dependencies gets downloaded as well. And there's like, you can like use spec packages. You can pin them to like a specific version or leave them open at this level of the abstraction. We'll see in the next slide that there's also what we call the Anaconda project lock that locks all your dependencies so you get exactly the same versions when someone else tries to run your project. And we also have a lot of flexibility, so you can specify your packages in that level, or you can also, if your project for some reason requires multiple environments, let's say you have a notebook that depends on a specific version of pandas, another version that requires another version of pandas, you can still maintain both dependencies in the same project environment. So really it's like one project to multiple environments. The same also is true for the deployment commands. You have for one project, you can have multiple commands because you might want to serve all of these different assets that we've seen previously. So as we've seen, like it helps you define and management the deployment commands, downloads, and other external data sources, the project package dependencies, including multiple environments, and then environment variables are also like pretty often used when you need to like require tokens. If you're connecting, for example, to the GitHub API and you need to like generate a token and like keep that safe as a dependency in your project. What the Anaconda project does then, if it doesn't like ship that necessarily, it doesn't have to ship that token with your application, but it might require the person consuming it having to input their token to be able to like run it as well. So it keeps track of those different options. So as I mentioned earlier, because you can kind of keep the dependencies, not to the kind of build or version pin, it's still like, you could say, well, that's not full reproducibility, right? Because like if today I Conda install pandas, and tomorrow there's a new release of pandas, when I Conda install it again, I get the newer version if I don't pin the version, right? So what Anaconda project lock is trying to like solve is for those occasions that things get updated with you having the control. And so in this case, it generates this file for you. You don't have to manually edit this file. It's when it runs the project, it solves all the dependencies, exact dependencies that were downloaded for your project. And it even also, as you see here, there's a field for platforms. So for different platforms, the dependencies of our project might be different. So in this case, you can see that there's like, even if I just like said, I want, like general 3 packages, when it goes and tries to like install all the second dependencies of those libraries, etc. There are some that might be like specific to just like Unix systems, specific that are only for like OS X or Windows. So it keeps track of all of that. Even if I'm running on a Mac machine, it generates the dependency that someone would have if they were to run the project in a Linux system or a Windows one. So then I can send this Anaconda project to anyone, and they'll get exactly what they need to run that project, no matter what platform they're in. So having said that, we'll see that then Anaconda project builds on top of the Anaconda distribution in Conda to bring additional capabilities to manage your data science for reproducibility and development. So now pretty much you have your project in your laptop or in your desktop, different Anaconda projects, and now when you like share with someone else, no matter what laptop or desktop system they're in, they're going to be able to like do Anaconda project run and get exactly what they need, as well as being able to like serve all the different deployment types that you've defined on your project, and see them on their system and see them how they're going to look once you've deployed them. So in summary, with Anaconda project, data scientists can now export those environments with exact pin versions across all the platforms, manage other additional dependencies like data, variables, commands, and services, and then like get the right abstraction for data scientists, right? You don't have to get into like some of the weeds that Docker makes you go through, because like you just don't care as a data scientist, like all of that low-level details. So, we then saw kind of like, we did like open source Anaconda project, and then we defined, okay, how are we helping the community solve that, reproducibility and deployment, challenges. And then we say, okay, what can we add as an extra value for enterprises, and what do they care about, right? And in that case, what they really care about is security and scalability, to make project collaboration and deployment very easy. So that's what we've done in Anaconda Enterprise. We take care of like all these like Docker and Kubernetes orchestration for companies, so that data scientists only have to worry about the right level of abstraction. And we also take care about all the permissioning model behind it, so that both for project collaboration and editing, and also for data science deployment, or those deployments that you've generated, you can share those projects with with other people or even with other applications by generating a token and a URL that then they can consume via REST API. So that's one, like, just to give like some visuals of what these different deployment types look like. Once you have an Anaconda project and you deploy through one of those commands, some of those, as I mentioned, can be like notebooks. In our case, we define self-service notebooks because a lot of times what you want is give people the permission to run them like whenever they want to get the updated results of like your if it's like some data updates running a report. They might want to like self-serve and select, I want to get the latest reports on like our sales. And so, but you don't want that salesperson or that marketing person, like hacking away your notebook. So that's when we say like there's a deployment type of just like run-only notebooks to like satisfy that need. There's like the bokeh dashboards, if people are familiar with that, so that people can like, you can expose the data exploration to people that can like now use the widgets and like drag and drop, select and filter with the bokeh application. We also have the serving model via REST APIs. So basically, if some of you were in the Fusion talk yesterday, we saw that it would just take data scientists to like write a decorator in their functions with @Fusion register. In the case of the machine learning REST APIs, it's just like Anaconda publish, and so you add a decorator @Anaconda publish to your function, and then the package takes care of turning that into a REST endpoint. And then because it's like so flexible, you can also deploy just general web applications. So a Flask Python application can also be wrapped in an Anaconda project. And in this case, and we'll see in a demo now how you can like write this just like very simple Flask application where you upload an image and it classifies for you. So you can imagine exposing that to the consumers that want to use the data science that you're building in a very simple manner. So I'm just going to show an example of like this general web application deployment that has some machine learning in it. In this case, as I mentioned, is like the image classification. So basically, I just like have one-click deployment that takes care of spinning up the Docker containers, the Kubernetes cluster, and everything, and then just like clicking upload, having the pandas, and getting the results back that I've used TensorFlow to decide what's in the picture. I have a similar example with a snake, so I upload the snake, and then it gives me the results back of what it thinks it's on the image. So this makes it very simple to deploy. It's just like you just write the Flask application. You have the dependencies in your Anaconda project spec, and then in Anaconda Enterprise, we've just made it very easy, like to click a button, and then you have this that now you can share with other people, and we take care of also the permissions to see interact with the application. Additional enterprise capabilities that we've heard our customers need and want is on collaboration. So if I'm in my Anaconda Enterprise JupyterLab environment editing my project, and I want to save it, and I want to easy git, that's what we're being told. So it's just like a save button that now gets to commit it, and then I'm able to go to like someone else. So like this is like now Daniel that wants to share that project with another collaborator so that they can also edit it. So now he's sharing it with me, Christine, and now I'll see this new project show up in my list of projects, and now I can open it and edit it as well. And this takes care of managing all the files being shared between me and Daniel as well. So now I'll get the project that Daniel has, and I'll decide that we need to have another notebook to train, to build a model to train our analysis, and I'll then like save it again, commit it, and then Daniel is gonna get the, my note that I want a notebook with the model that he's trained. So this checks like all the differences, like making commit messages, and then also saving those deployment revisions so that like when you select deploy, you don't have a long list of all like the times like you've committed or saved a notebook, and just the ones that you want to tag it like this is ready for other people to consume. And as you can see, and we'll see a little bit more later, the default experience in Anaconda Enterprise is the JupyterLab environment, but we also support the classic notebook view. So with this, I hope you've seen how with Anaconda Enterprise, data scientists can easily deploy the project in a wide variety of deployment types, like the notebooks, the REST APIs, the dashboards, and the web apps, collaborate with other data scientists, and then we take care of the security model to share those deployments with other applications as well as with other users. So as I just like mentioned, JupyterLab is the default experience in Anaconda Enterprise. We've been working very hard and like together with the JupyterLab team to make sure that it's ready for users and for prime time. And we've got a lot of like positive feedback on the like usability and how having all this, like combining all the different interfaces that you need to do your data science, not only like the notebook view, but like be able to like easily and very fast prototype things in like the terminal or in like the IPython, like just like the IPython view has really helped in like the markdown thing, like how things are going to look once you've deployed them. Like that's been a very that really helps data scientists manage their entire flow from one view and make them more productive. So I don't know if Nick is here. I don't think he's here, but Nick is like one of our developers. He's like a Jupyter contributor, and he's been working to build this Anaconda project lab extension that you can see here inside of JupyterLab. And this is like a UI that takes care of all like these different things that we've said that Anaconda project takes care of you in this config file. Now you can manage them through the UI directly inside of JupyterLab. So you can see like the commands field, the different platforms that you're going to be supporting when you log the file, the channels where you're getting the Conda packages from, the environment variables that you need to set up to run your project, or like those downloads, or the like then like the environments, like the different environments that you have, and then the packages that are in each environment. So I have demo here where you can see I look at the different environments that I have. In this case, I just started with a very basic environment with just let me go like with just like Python and the IPython kernels, and I get like the like the constraints I've set up in my environment, and then like the exact version that I'm getting, and so sorry. And then once I have that, I can prepare my environment and get all this different kernel, like all the different kernels for each of the different environments that I have. And then I can update those environments with new packages. And it actually does like the, so in this case, what it has done, okay. In this case, what it has done is like now I have like my root environment where JupyterLab is running, and like I have those like kernels, so I can like edit, add more extensions that I want in my JupyterLab environment, and then at the same time I also have the kernels available of the different environments that I've set up. So you could have in like your same JupyterLab view, in this case I had like this default environment, but if I had another with another name, if I want to have for some reason multiple versions of packages. I can prepare all those different environments, and now I get all those different kernels to like play around it. And I have one version of pandas here, one version of pandas there, and versions of like, for example, scikit-learn, etc. So like really getting all those kernels and being able to launch them directly from the launcher page. So in this case, then like as I mentioned, you might want to decide that now you want pandas. So directly inside of JupyterLab, I can search, and it actually goes and like searches through like all the channels that I've like configured and set up. So I get like a, it does like the search on if you have an Anaconda cloud or an internal repository of Conda packages. It goes and searches for those names, and you can actually select what versions you want directly from the UI. So in this case, I want pandas. I don't select what exact version I want, just like add the plus, and I get the latest. So now it goes and fetches the Conda pandas package, installs it in this environment, and now if I go to like the default kernel, well, you'll see here that now I get that 0.23 version, and now if I go to my notebook, I get the pandas package installed. So it makes it very seamless to like go from like your Jupyter, just like do all your activities from one environment without having to switch. So you have your terminal, you have like the UI to manage those like downloads that you might need, like those packages that you might need, and then also defining the commands of like what you want to like expose once you deploy your project. So a little bit as a summary, Anaconda helps data scientists reproduce and deploy their projects, and you can kind of decide what level of help you need, right? So there's like, with the Anaconda distribution Conda, you can manage your software packages across those different platforms, isolate and recreate the environments for people to like collaborate with other people, or when you like ship them on a server. With Anaconda project, then you get kind of like a next level of capabilities in terms of reproducibility in deployment. You can now export environments exactly with their pinned versions for all those cross-platforms. You can now add other dependencies that your project might have, like data variables, commands, and services. And then you don't have to worry about like all the Docker details if that's how you've been managing your data science deployment so far. And then with the enterprise product, we add kind of like enterprise features that our customers need, like being very easily like just like hitting one button to deploy those projects instead of having you to like stand up those servers, provisioning them, and then like defining how you want to orchestrate your resources. You can also get like this like collaboration with other data scientists with a Git server and like the commit system, and then like you can securely share those deployments with other applications and users. So like my slides are going to be up in speaker deck, also like at Twitter. I'm also going to be like tweeting them if you want them, and I think I'll take some questions now. Thank you.
In the slide that you showed an example, you had notebooks up the top and dashboards underneath. I couldn't tell whether dashboards are just notebooks, or are they something more than that or different?
Great, thank you. Thank you for your question. So there's different types of dashboards that you can build in Python. Specifically, this one is like a bokeh app. So it's built using bokeh to build this dashboard. But then there's been like other projects like the Jupyter Dashboard project, where you could also build dashboards from a notebook to convert a notebook to a dashboard. In this case, it's a bokeh app. So it's like mostly like a Python script that you can run, and then it's a very few lines of Python code, and takes care of a lot of the HTML, creating the HTML and JavaScript for you to create these like different widgets and interactions.
Could you talk a bit about which aspects are part of the open source Anaconda project and which aspects are part of Anaconda Enterprise, particularly the read-only notebooks example that is at the top of this slide?
Yeah, so what's open source, the Anaconda distribution, Conda, and Anaconda project, all of those three like are open source and available with the Anaconda distribution. The notebooks is actually a notebook extension called NB Run Only. Yeah, so I believe that one's like also like a free extension, an open source extension. And then like the enterprise capabilities, as I mentioned in this, like the last slide, I think it's like the one that summarizes the best what it's like when you see like something that's in like the enterprise level, like the committing and saving or the permissioning or the actual like from one click to deploy, that's kind of part of the suite.